Morning, physicsy people. So I've got a Rubens tube. A Rubens tube is a tube that has a whole bunch of holes drilled in the top of it. I've got a balloon that I cut so it's only one layer deep, kind of stretched it tight across there, and then we set it here. That is connected to the gas, and so I will turn the gas on. And we can do that and make a whole bunch of little candles. Right? Oh, ooh, apparently that was leaking a little bit there. Okay, so we can kind of see that. Why don't we move this way a little bit more and angle this guy a little bit more so we're more to the side. Is that good? Yeah, now we're a little bit more to the side. Good. And so then I'll cut this down a little bit. So the point of this is that we can kind of visually see a sound wave, right? So as if you push harder on this, that's going to force more of the air out of there. So I've got a tone generator set up on my other computer, and we'll set up some tones and see if we can see something. Well, first, yeah, let's do the tones. So we'll come down here and kind of look for one. So there's a tone. If you look, you can't really see a whole lot right there. If y'all can help me watch for one. There we go. Kind of start to see one there, right? So we can kind of see a peak right here. And now a standing wave, right? A standing wave is one that's going up and down. So that's not one wave. That's actually half a wave right there. So each peak, it would be from like a low point to a low point, and it would have to go clear over here to another low point to get a whole wave, right? So we're seeing about half a wave right there. If I go to a higher frequency, that's going to be enjoyable to listen to. You can kind of see when we're not at a standing wave where it's at, and then you can see when we get to standing waves. This one isn't as long as I would like. I'd like to have a little more. There we go. I'd like to have a little more length on it. So I've got, your quiz is actually based on a YouTube one where that one was real long, so you can get the peaks in there really nicely. But this one, we can kind of see two full waves there, right? So if we go two full waves, if I go from here to about here, right? So that's two full bumps. So that's right about 80 centimeters. So if we did 0.8 times my frequency is 586. So if I did 0.8 times 586, 0.8 times 586, that gives us a speed of 468, right? So 468 meters per second. You're going to basically do that in your quiz, but with the one that guy did. You're not going to get similar numbers because this is methane. Methane's way less dense than air, and propane is more dense than air. So I should stop the annoying sound in the background. So methane's way less dense than air. Propane's more dense than air. So the more dense, you end up with very different wavelengths, and you end up with a less dense one there, right? So some fun stuff you can do with this is you can like play music with it and stuff. If you have like hours to kill with nothing to do at home, like a lot of us do right now, there are way better Rubens tubes out there. And you can catch those and jam out all you want. But this one's not long enough to get really, really nice stuff. You can kind of see when the beat hits on there and stuff a little bit. Here, we gotta find a better song. Black Sabbath. Oh yeah, you can see that pretty well. All right, anyway. So that's how Rubens Tube works. Those are kind of fun. I've made others. I've got one that I like better over here, but it doesn't actually work. But it's longer and all that kind of stuff. All right, thanks.